Assalamualaikum. My name is Muhammad Adam Merohaizi. My metric number is CD200040, and today I would like to explain the application of fluid mechanics in land wind turbine. For the introduction, wind energy is created when the atmosphere is heated unevenly by the sun, causing some patches of air become warmer than others. This warm air rises and other air rush in to replace them, hence wind blows. The first electricity generating wind turbine was invented in 1888 in Cleveland, Ohio by Charles F. Bush. Wind turbine is a device that converts kinetic energy from the wind into electrical power. Wind turbine extract the energy from the wind by transferring the momentum of the air passing through the wind turbine rotor into the rotor blades. The rotor blades are aerofoil and used for concentrating the energy in the airflow into a single shaft. This is the first picture of the automated wind turbine by Charles F. Bush. There are two types of wind turbine. And the first one is wind turbine using leaf foils, which is horizontal axis wind turbines. There is type vertical axis. And secondly is wind turbine using direct force.
Assalamualaikum warahmatullahi taala wabarakatuh, and very good morning to all audience. My name is Muhammad Syami bin Yaakob. I will present about application wind turbine with fluid mechanics. Wind turbine utilities fluid mechanics a principle to convert the kinetic energy of wind into mechanical energy, which is then transformed into electrical energy. Fluid mechanics play a crucial role in the design, operation, and efficiency of wind turbine. Firstly, application wind turbine with fluid mechanics is aerodynamic. Wind turbine rely on the principle of aerodynamic to capture the energy from the wind. The interaction between the moving air and the turbine's blade is critical in granting lift and torque. Secondly, airfoil analysis. The airfoil shaft of a wind turbine blade is carefully designed to achieve excellent lift to drag reaction. Fluid mechanics principle, which as Bernoulli principle and the Navier-Stokes equation, example to analysis and optimize the airflow around the airfoil. Lastly, turbulence and flow analysis. Wind turbine performance is influenced by the complex flow pattern that turbulence in the surround air. Understanding the behavior of the wind as it passes through the turbine is crucial for efficient power generation. Fluid mechanics is an integral part of wind turbine design, optimization, and performance analysis. By leveraging the principle of aerodynamic, load analysis, and structure mechanics, engine can enhance the efficient, reliability, and cost effectiveness of wind energy system. That's all from me. Thank you.
Ya, Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Faisal Irfan bin Wan Sahimi. and I will continue with the presentation about the parts and major parts functions of the wind turbine. So the first one, before I will go to deep about the explanation about the function of the parts, so I will tell you the first the structure one by one that we can see and study about the structure of the wind a bit clearly. So the first one is wind direction, which is we can see the arrow from the front of the blade of the winds of the wind turbine. So the second one is rotor, the third is pitch, and the fourth is low speed shaft, and the five is gearbox in between of the shaft, in between of the blades and the back side of the wind turbine. And number 6 is generator, and number 7 is controller, and number 8 is anemometer, and number 9 is wind vane, and number 10 is nacelle, and number 11 is high speed shaft, and number 12 is tower, number 13 is blades, and number 14 is yaw motor, and next is yaw 15 is yaw drive, and 16 lastly is a brake. So I will explain the parts by parts about foundation, about the details of the about the structures of the wind turbines. So the first one is foundation, where it is a large and heavy structure block of concrete, and it holds the whole turbine and the force on the winds. So the second one is tower. Tower, which is in where it holds. Where you can see the tower is the things. It's like and the tower is it's like the things that hold the wind turbine. So around the stick of a diameter of uh, 3 into 4 diameter, and it height of 75 to 101 meter, which is depends on the size of the turbine and location. So the third one is rotor. It is a rotative part of a turbine and consists of three blades mostly, and the center part known as hub. So we continue with the next structure or parts of the wind turbine, which is the hub, where it holds the blades in a position and able to rotate with respect to the rest of the turbine body. So the second is nacelle, is a housing on top of the tower which protects all the components such as gearbox, turbine, shaft, and generator. Where we can see the nacelle is the things that protect all the components, which is the shaft, with the and generator and the gearbox itself. So lastly is generator, where it converts the mechanical energy of the rotor to electrical energy, which is same as electric motor. So I think that's the structure which is I think that we must learn must know about the wind turbine. So we can go and relate with the application about the wind turbines with the fluid mechanics. I think that's all for me. Assalamualaikum.
Hi and greetings. My name is Wan Ahmad Firoz bin Wan Muhammad Zulkifli. My metric number is CB200046. And today I will present the formula to calculate the power output of a wind turbine. First of all, formula for P is 0.5 times P times A times Cp times VQ. P is the power output of the wind turbine in watts. and P is the density in kilogram m cube. A is the swept area of the turbine blades in square meters, while Cp is the coefficient of performance or power coefficient dimensionless. And lastly, V is the wind speed in meter per second. The power coefficient or Cp represents the efficiency of the wind turbine in extracting power from the wind. It depends on the design and characteristic of the turbine, because wind turbine have many design and characteristics, so the power coefficient or Cp is it depends on the design because it has different design. Okay, and after that it is important to note that this formula provide on approximation and the actual power output of a wind turbine can be influenced by various factors such as wind shear, turbulence, mechanical losses and generator efficiency. And we will go to the next slide. Hi, for the next slide I will present windmill application. This is where the windmill can be found and can be applied. Okay, firstly, farm windmill. Secondly, golf course aeration. Thirdly, cattle farm windmill. Fourthly, pond aeration. Fifthly, residential water aeration. And sixthly, fish pond and hatcheries. And lastly, West Nile virus prevention. Okay, and for the conclusion, in this work, a mathematical model for the fluid dynamic design of a wind turbine based on cloud theory has been implemented. The mathematical model is known as the black element momentum theory, and start from the cloud propeller theory with suitable multiplication for application to wind turbine. This model can be implemented for the study, design and evaluation of wind turbine and rotor performance. And that's all from me. Thank you.